Hello, ladies and gentlemen. Today our topic is constant of proportionality, and our objective is that you will be able to identify the constant of proportionality in 4 different ways: graphs, charts, verbal descriptions, and equations. You should be on page 54. It is December 5th, and I'm going to try and pick up the pace of today's video because I think that I've been getting a little bit long. So I'm going to go quick, okay? All right, so let's talk about what the constant of proportionality is. This can go on the same page. The constant of proportionality is simply a number that describes the relationship between two things. Okay, so the variable that we use for the constant of proportionality is k, and here's the fancy math definition: the constant value of the ratio of two proportional quantities x and y, usually written y equals k times x, where k is the factor or constant of proportionality. Okay, so that's a lot of math speak. Pretty much what I want you to take out of it is that this equation here, y equals k times x, is the kind of standard form of a proportional relationship. Notice that it's very similar to y equals mx plus b, except instead of an m, it's a k, and there is no b in our proportional equation. K and m, guys, honestly, they're incredibly similar. They both describe the slope. They describe how steeply a number increases. The biggest difference between this linear function and this proportional relationship is that the proportional relationship goes through the origin, which is the point 0, 0. And this equation is going to be moved up or down the y-axis by b, the y-intercept. Okay? So there's really no earth-shaking, ground-shattering changes to what you've already been doing for the last month and a half. It's just calling it something a little different. So let's look at how we actually find the constant of proportionality. And you did a little bit of this yesterday in class. So in class yesterday, you guys had some tables, and it asked you to find the ratios of y to x. So write this chart down and then put a third column on it that says y over x. A lot of you guys did x over y, if you remember, and I had to remind you it says y over x. One way you can remember that, if you think about slope, slope is the change in y over the change in x. And I told you that slope and the constant of proportionality have a lot in common. So when we're finding our constant of proportionality, we're going to use the same order that slope uses, y over x. So here I'm going to make a fraction 8 over 2. I'm going to do 20 over 5 and 1.6 over 0.4. The next step you need to take is you need to take all of these different ratios and then divide them, okay? So I'm going to do 8 divided by 2, which is 4. 20 divided by 5 is 4. And 1.6 divided by 0.4 happens to also be 4. From the work we did yesterday, you should know that because these are all the same, they describe a proportional relationship, right? They have to have the same ratio to be a proportional relationship. And that number that you came up with when you found those ratios, that number right there is k. It's your constant of proportionality. And what's really awesome about finding k is if you know that the standard form of a proportional equation is y equals k times x, and you figure out what k is, writing the equation is incredibly easy. You just plug the number that you found for k into the standard form, and there you have it, your equation of this relationship shown in this chart. All right, so I think we can fit this on the, oh, no, we're going to go on the next page for this one. Sorry, I thought we were going to put it on the same one. Now let's look at how we can find it in equations. Well, based on what we just said, how you can find the constant of proportionality and then plug it into your equation, this should be pretty easy. The constant of proportionality of this equation is simply 4. It's the number that is multiplying by x. That's it. Make sure you do this on a new page. It should be page 55 on December 5th, 2013. So now let's look at graphs. This is, yet again, something that you have already worked on in my class. We talked about finding unit rate on a graph. That was your homework from last night. And you guys did really well on the homework from last night. If you remember, all we have to do to find the unit rate on a graph is to go over to 1, which would be right here, follow that line up to the graph, and then take that over to the y-axis, and that's going to put us here at 2. So our unit rate is 2. Guess what, guys? That is the same thing as your constant of proportionality. So see how all of these different things are kind of coming together? Slope is the same thing as unit rate. It's the same thing as the ratio that determines if numbers are proportional. It is the same thing as the coefficient of x. It is the same thing that you have been working with for weeks. So just like we could before, we can take this constant of proportionality and make it an equation. Standard form of a proportional relationship is y equals kx. Plug our unit rate into that equation, our k into that equation, and we get y equals 2x. That's the equation of our line. All right, last, let's look at verbal descriptions. This is the one that might be slightly tricky. When you're looking at verbal descriptions, you have to first ask yourself, is it proportional? And the only way a verbal description, also known as a word problem, the only way a word problem is proportional is if the same amount is changing every single step of the way. What on earth does that mean, Mrs. Ott? It means that in this situation we have John. John is mowing lawns to earn some money, and he earns $7 for every hour he spends mowing. Period. That's it. Simply $7 an hour. That is a proportional relationship because every single hour he gets $7 more. So after 1 hour, he gets $7. After 2 hours, he gets $14. After 3 hours, he gets $21. Each time, my ratio of how much he earns to how many hours he works is 7 over 1. This 14 over 2 simplifies to 7 over 1. 21 over 3 simplifies to 7 over 1. So what would my constant of proportionality be? K equals 7. And you don't even have to make this chart to see that. Once you figure out that it's a proportional relationship, all you have to do is look at the number that is being used each hour or minute or each time John mows a lawn. You can then also take this, make an equation. Y equals, oopsie, ooh, bad Mrs. Ott. Y equals 7 times x. Simple as that, guys. All right, at this time, your reflection is to find the constant of proportionality for this table. Be careful, I tried to trick you. And then I also want you to write the equation. Okay? All right, guys, I will see you tomorrow, and have a good evening.